Your teenager just told you they want a 3D printer, and you're staring at a page full of specs that might as well be written in Klingon. Before you panic or reach for your wallet, here's what actually matters. The right machine teaches engineering through failure, not just success. I'm Dr. Priya Mehta, a child developmental psychologist who specializes in how kids learn computational thinking through hands-on tools. Welcome to the STEM Lab podcast. Quick thing before we get started. Everything you're about to hear, all the research, the recommendations, the script, that's all written and verified by real people, real experts. But the voice you're hearing right now, that's AI. Just wanted to be upfront about that. If you've been listening for a while, thank you. Seriously, it matters that you're here. And if you're brand new to the show, we're really happy you gave us a shot. We drop new episodes every Monday, Wednesday, and Friday, so you'll never run out of things to listen to on your commute or your morning run. Today, we're tackling a question I get all the time. How do you pick a 3D printer for your teenager that actually teaches them something instead of just taking up space in the garage? Let's jump in. You're watching your teenager move beyond ready-made projects, and you're wondering, are 3D printers for teens really worth the investment, or just another complicated device collecting dust? The right 3D printer becomes a skill-building workshop that transforms abstract CAD concepts into tangible engineering prototypes. Below, you'll find 9 carefully selected 3D printers for teens that balance educational value with real-world capability. Each one is a stepping stone toward industry-standard manufacturing skills. Let's start with the Creality Ender 3 V3 SE. This printer offers your teen unfiltered access to the same FDM technology used in professional prototyping labs. This open-frame printer requires active learning. Bed leveling, adhesion troubleshooting, and temperature calibration all become hands-on lessons in material science. Your teen gains authentic problem-solving experience with this model because it doesn't hide the mechanics behind proprietary software. The trade-off for this transparency? Expect failed prints during the first week while they learn proper bed leveling techniques. The sensor-assisted leveling helps, but doesn't eliminate the learning curve entirely. You're looking at a build volume of 220 by 220 by 250 millimeters, and it'll work with any standard outlet. Check the show notes for a link to the current price. It's compatible with open-source Cura Slicer software on any operating system, and you can run it completely offline once you transfer files. No subscription required, but budget around $25 to $30 monthly for PLA filament, depending on how often your teen prints. The open design means you'll need a dedicated printing area. This isn't a kitchen counter device, given the heated components and occasional filament odor. Moving on to the Bamboo Lab A1 Mini, this one removes mechanical friction from the learning process, letting your teen focus on design iteration rather than printer maintenance. Automatic bed leveling and filament detection mean more time in Tinkercad or Fusion 360, less time troubleshooting hardware. This enclosed design addresses safety concerns you might have about heated nozzles and moving parts, making it appropriate for shared family spaces. Within 2 months, expect your teen to progress from printing downloaded models to designing custom enclosures for Arduino robotics projects or science fair prototypes. The 180 by 180 by 180 millimeter build volume handles most educational projects: phone stands, renewable energy component mounts, custom gear assemblies. Check the show notes for a link to the current price. The main limitation, that smaller build volume becomes restrictive for ambitious multi-part assemblies, and the proprietary Bamboo Studio Slicer locks you into their ecosystem. It's free, but it's required. Cloud-dependent features like remote monitoring require account creation, though basic printing works offline. Now, let's talk about the AnchorMake M5. This printer prints at speeds up to 500 millimeters per second, which matters more than you might think for teenage attention spans and iteration cycles.
Fast print times mean your team can test 3 design variations in an evening instead of waiting overnight for each attempt. Built-in camera monitoring teaches documentation habits. They'll capture time lapses of their prints, building portfolios that demonstrate both the final product and the manufacturing process. You're looking at a 235 by 235 by 250 millimeter build volume with a Core XY motion system. It requires stable Wi-Fi for camera features, compatible with Anchor Make Slicer or Cura, partial cloud dependency for remote monitoring. Check the show notes for a link to the current price. The AI-powered error detection occasionally triggers false alarms on legitimate bridging techniques, which can frustrate advanced users who understand they're pushing the printer's capabilities intentionally. No consumable subscriptions, but the proprietary nozzle design costs $15 to $20 for replacements, more than standard compatible options. This printer fits into a progressive STEM learning path by introducing manufacturing speed as a design variable. Your team learns to optimize not just for strength or aesthetics, but for production efficiency. The Alegu Neptune 4 Plus offers a generous 320 by 320 by 385 millimeter build volume that accommodates full-scale functional prototypes instead of miniature proof-of-concept models. Your team can print a complete wind turbine blade assembly in one piece, rather than gluing together sections. This capacity matters for science fair projects, where presentation quality and scale directly impact judging outcomes. Clipper firmware provides advanced users access to real configuration files and G-code customization, the same low-level control used in professional fabrication environments. The Alegu Neptune Slicer supports offline operation, or your team can graduate to more sophisticated tools like Prusa Slicer. Direct Drive Extruder handles flexible filaments like TPU and TPE that other systems struggle with, expanding material possibilities. Check the show notes for a link to the current price. The honest limitation here is physical footprint. This 18 by 18-inch printer needs dedicated desk space, and the cooling fans run at noticeable volume during long prints. No subscription required, but larger builds consume filament quickly. Budget $40 to $50 monthly for active project schedules. Let me tell you about the Prusa Mini Plus. This represents genuine engineering heritage. Prusa Research publishes their designs as open-source hardware, demonstrating the maker philosophy your team should internalize. This printer becomes a teaching tool for mechanical principles because every component is documented and explainable. Removable spring steel print bed with textured PEI surface eliminates adhesion guesswork while teaching proper material handling. Prints pop off when cooled, no scraping required. You're looking at 180 by 180 by 180 millimeters build volume. 32-bit board with silent stepper drivers, works with any standard outlet. Check the show notes for a link to the current price. Prusa Slicer offers genuinely helpful profile presets for over 200 materials and provides detailed explanations for each setting. It's educational software, not just printer control. The company's knowledge base includes troubleshooting guides that teach material science concepts alongside solutions. The trade-off for this educational approach? Assembly required, 4 to 5 hours with your team following detailed instructions. That's actually an asset. They'll understand the mechanics intimately. Replacement parts ship from Czech Republic, meaning 7 to 10 day wait times versus next day Amazon availability. This printer prepares teams for industry-standard workflows used in product development labs worldwide. Now, the FlashForge Adventurer 5M addresses your practical concerns about integrating industrial equipment into family spaces. HEPA filtration and fully enclosed print chamber contain ultra-fine particle emissions and odors, making it appropriate for bedroom or kitchen placement. The camera monitoring and mobile app mean you can supervise print progress without hovering, important for building independence while maintaining safety awareness. Your team will learn proper ventilation considerations and material safety datasheet interpretation, critical skills if they pursue manufacturing or laboratory careers. Quick Swap Nozzle System lets them experiment with different nozzle sizes without frustration, teaching how resolution and speed trade off against each other. The 220 by 220 by 220 millimeters build volume handles standard educational projects. Check the show notes for a link to the current price. The proprietary flash print slicer works offline, but lacks the advanced features found in open-source alternatives. You're trading customization sealing for user-friendly onboarding. Nozzles cost around $15 to $18 each as proprietary components. The touchscreen interface occasionally lags during menu navigation, a minor annoyance rather than a functional limitation. The Soval SV06 Plus delivers 300 by 300 by 340 millimeters build capacity at a price point usually reserved for smaller machines, making it valuable for cost-conscious families supporting multiple student interests. Your team can tackle ambitious multi-part assemblies without compromising other enrichment activities.
Direct drive all-metal hot end reaches 300 degrees Celsius, unlocking engineering-grade materials like PETG and nylon that better simulate professional prototyping workflows. Marlin firmware with open-source configuration files, compatible with any slicer software. Completely offline capable after initial setup. Check the show notes for a link to the current price. The power resume function saves prints during electrical disruptions, useful for overnight prints in storm-prone regions. The build surface requires manual bed leveling, though the 25-point auto-leveling mesh compensates for minor variance. Here's the honest friction point. The included flexible build plate loses adhesion after 30 to 40 prints and needs replacement, around $20, and the Chinese to English manual translation contains confusing sections. Budget time for community forum research alongside official documentation. This printer works beautifully alongside Python programming education, as teens can write custom G-code generators for parametric designs. Let's look at the Artillery Sidewinder X2. This one features a volcano-style hot end that melts filament at accelerated rates, enabling layer heights up to 0.6 millimeters for rapid prototyping, when surface finish matters less than speed. Your team learns to match process parameters to project requirements, a fundamental engineering skill. The 300 by 300 by 300 millimeter build volume accommodates vertical assemblies that would require splitting on smaller printers, teaching single-piece design strategies over multi-component approaches. Direct drive extruder, silent stepper drivers, ultra-base glass platform requires 110-volt outlet with 400-watt capacity. Compatible with Cura and Simplify 3D, fully offline after file transfer. Check the show notes for a link to the current price. The touchscreen firmware occasionally requires updates via micro SD, a valuable troubleshooting skill, but something to factor into your setup expectations. The AC heated bed reaches target temperature in under 3 minutes, reducing waiting time between projects. The cable management on the X-axis gantry can pinch if not routed carefully. Your team will learn proper preventive inspection habits. No subscription fees, but quality PETG filament runs $25 to $30 per kilogram, and this printer's speed encourages higher usage rates. Finally, the Kingroon KP3S Pro offers 200 by 200 by 200 millimeter build volume in a remarkably compact footprint, making it practical for dedicated teen STEM lab spaces where desktop real estate is limited. The Titan Direct Drive Extruder provides consistent extrusion pressure for detailed mechanical parts, gears, bearing mounts, threaded inserts. Your team will appreciate the direct connection between design tolerances and print success with this machine's 0.05 millimeter layer resolution capability. Core XY kinematics deliver precise positioning. Auto bed leveling probe requires standard outlet. Compatible with Cura, Simplify 3D, Prusa Slicer. Fully offline capable.
Check the show notes for a link to the current price. The glass print bed provides excellent flatness but requires glue stick application for PLA adhesion, a minor preparation step that becomes automatic. The genuine limitation here is build volume for larger assemblies, but this constraint actually teaches design efficiency and modular thinking. The cooling fan placement creates directional cooling bias, requiring strategic part orientation for overhangs, a nuanced skill that translates directly to professional engineering workflows. So, how did I make these picks? I evaluated these 3D printers for teens through the lens of skill progression rather than feature checklists. Each printer needed to offer transparent access to the underlying mechanics. Proprietary black boxes that hide the printing process don't teach problem-solving skills. I prioritized machines that balance immediate success with genuine challenge, recognizing that your teen's first failed print holds more educational value than 20 successful downloads from Thingiverse. Durability standards included continuous operation capability for 8-plus-hour prints, widely available replacement parts, and active community support for troubleshooting. I excluded printers requiring proprietary filament cartridges or mandatory cloud subscriptions. Those artificial limitations undermine the open-ended exploration that drives authentic learning. Build volume needed to accommodate science fair scale projects without being so large that print times discourage iteration. I tested each printer's compatibility with professional slicer software like Cura and Prusa Slicer, ensuring teens could graduate to advanced features without switching platforms. Safety considerations included thermal management, electrical certification, and ventilation requirements because your teen's workspace should support their independence, not require your constant supervision. Let me answer some questions you probably have. Do teens really need 3D printers that cost nearly $500, or would a cheaper model work just as well? The $300 to $500 range delivers reliability and capability that prevents your teen's learning momentum from stalling on hardware limitations. Cheaper printers often teach frustration tolerance more than engineering skills, while machines in this category balance accessible onboarding with genuine growth potential that extends through high school projects and into early college or maker careers. What's the difference between enclosed and open-frame 3D printers for teenage users? Enclosed printers contain odors and regulate temperature for better print quality with engineering materials like ABS, but open-frame designs provide transparent access to the mechanical systems that teach troubleshooting and maintenance skills. The choice depends on whether your priority is minimizing supervision requirements or maximizing hands-on learning depth. How much ongoing cost should I budget for filament and maintenance? Expect $25 to $40 monthly for filament if your teen actively pursues projects, plus occasional nozzle replacements, $10 to $20 annually, and build surface refreshes, $15 to $30 as needed. No subscriptions required with any printer on this list, though cloud monitoring features on some models need free account creation. Which 3D design software should my teen learn alongside their new printer? Start with Tinkercad's browser-based interface for immediate gratification, then transition to Fusion 360 for parametric modeling that mirrors professional CAD workflows used in mechanical engineering and product design. Both offer free educational licenses. Here's what matters most. The right 3D printer transforms your teen's relationship with physical objects. They'll start seeing the manufactured world as problems they can solve, rather than finished products they must accept. My own children stopped asking, "Where can we buy that?" and started asking, "How would we print that?" within weeks of accessing a printer. That shift from consumer to creator matters more than any specific project they'll produce. These 3D printers for teens represent genuine skill-building investments that compound over years, not entertainment purchases that lose appeal after initial novelty fades. Choose based on your teen's current skill level and your family's space constraints, knowing that print quality matters less than print frequency for developing authentic engineering intuition.
That wraps up this episode of the STEM Lab podcast. Thanks so much for listening. New episodes come out every Monday, Wednesday, and Friday, so there's always something new waiting for you. If you got something out of this episode, I'd love it if you could leave us a 5-star rating and write a quick review. I know it sounds like a small thing, but it actually makes a huge difference. It's how other parents and educators find the show, and honestly, it helps us keep doing this. And make sure you hit subscribe or follow so you get a notification the second a new episode goes live. Thanks again. See you next time.